Hello, I'm Brian Farrell, and welcome to PACE IT's session on display devices. We're going to be talking about pixels and lumens. We're going to be talking about analog and digital displays, and then we're going to talk about types of display devices. There's a whole bunch of material to cover, so let's go ahead and get started. So let's start with pixels and lumens. I'm sorry, this is about pixels, not pixies. Now, pixels is a word that's made up out of picture elements, and it represents a basic programmable unit of color on a display device or computer image. In the modern display device, the pixel is a 24-bit block that is composed of 1 byte units of red, blue, and green, RGB. All the colors of the spectrum are composed by combining various intensities, byte values, of the color component. The pixels are combined and the image is formed. The more pixels that are present, the sharper the resolution. Now, resolution is a method of establishing how many pixels wide and tall an image is, which has an effect on the sharpness of the image. Pixels are logical in nature, which means that their size is not a set standard. In most cases, you, the user, can determine the resolution of the display. Now let's move on to lumens. Lumens are one measurement of light output or brightness. The more lumens that are present, the more light that is output. Some display devices are rated for more lumens than others, which can have an impact on where they are deployed. For instance, a display device that doesn't have a very high lumen count will not perform very well in a situation where there is bright ambient lighting. Now let's move on to analog versus digital displays. So let's begin with analog type displays. An image is created digitally inside the PC and delivered to the graphics device. The graphics card or the onboard PC graphics. The graphics device converts the image from its native digital format into a modulated electrical current format, that's analog, that is then delivered to the display. The display uses the analog format to represent the image on the screen. Analog screens tend to be slower in processing images on the screen. Now, many digital displays can receive an analog signal, which they then convert back into a digital format. Now let's talk about digital. A digital image is created and delivered to the graphics device. The graphics device transmits the image to the display device in its native digital format. The display device receives the digital image and represents it on the screen. It is the newer standard and tends to be faster than analog. Now let's move on to types of displays. And we start with the CRT, the cathode ray tube. Now this is an older standard. A CRT monitor uses a combination of a vacuum tube, an electron gun, and a fluorescent screen. It is analog in nature. The electron gun excites the individual pixels on the fluorescent screen, which then light up and present the image. Each line on the screen needs to be refreshed because the screen doesn't hold the electrical charge. The rate at which this is done is called the refresh rate. Too low of a refresh rate will cause the screen to flicker and cause eye fatigue. Now, CRT monitors tend to have very good color representation, and it's easy to adjust the resolution and get a good sharp image. Now let's talk about projectors. With projectors, the output from the PC is sent to the projector, which then transmits the image to a screen or wall. Now, projectors can either be analog or digital. The amount of lumens that the projector is rated for is important, as it will affect the amount of ambient light that can be present and still allow for the projected image to be seen easily. Now let's talk about the LCD display, the liquid crystal display. Now this is a type of flat panel monitor that uses an arrangement of liquid crystals and a fluorescent backlight to place an image on the screen. The liquid crystals are sandwiched between layers of glass and make up the screen that you see. An electrical current is used to change the alignment of the crystals, which then refract the fluorescent backlight, giving us the colored image. The liquid crystals do not emit any light by themselves. The light we see is actually coming from the fluorescent backlight. Because of this, LCDs do not do very well in bright environments. LCDs are a digital technology. Now, LCDs do have a native resolution for the screen. That is a pixel count that produces the best image. You can change the resolution, but you run the risk of distorting the image. With an LCD, the whole screen gets refreshed simultaneously, not line by line. LCDs are faster and consume less electricity than CRTs, but the color representation is not as good as the CRT. Now let's talk about LED displays. That's a light-emitting diode. LED displays operate exactly the same as LCD displays, except for one item. The LCD's fluorescent backlight is replaced with an LED backlight. Other than that, they are exactly the same. Now let's talk plasma displays. Now, plasma is a flat panel display technology that uses fluorescent cells contained in the screen. There's millions of them. An electrical charge is used to excite the cells and causes them to fluoresce in different colors, which causes the image to appear on the screen. This technology does not require the use of a backlight. Plasma displays work okay in brighter ambient light levels. It is also a digital technology. The plasma display does have a native resolution. Now, it does require higher voltages than the LCD or LED monitor. It also tends to be more expensive than LCD and LED monitors, but it also produces much better color than those two. It actually produces color on par or better than the CRT. Now let's move on to OLED monitors. That's organic light emitting diode monitors. Now this is an emerging display monitor technology. OLED is closer to LCD LED technology than it is to plasma technology. Instead of liquid crystals, the screen is composed of diodes that are sandwiched between thin layers of glass. An electrical charge is used to light up the diodes, which then place the image on the screen. OLED displays are thinner, lighter, and consume less energy than any other type of display. Except for the cell phone market, organic light-emitting diode display technology has not spread very far because of the cost of creating the monitors. The yield for the displays is very low, so they're difficult to make, which drives up the cost. Now that concludes this session on display devices. We talked about pixels and lumens. We talked about the difference between analog and digital displays, and then we talked about various types of displays. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing another one soon.